8 years ago, inside the 27-kilometer metal tunnel, which is the Large Hadron Collider at CERN, the world's largest particle physics lab, particles smashed together and the last piece of the standard model of particle physics was discovered. That was the Higgs boson. Named after the physicist Peter Higgs, who proposed it, the particle won the 2013 Nobel Prize of Physics. But what is it? The Higgs boson is an elementary particle which confirms the existence of the Higgs field. Okay, then what's the Higgs field? The Higgs field is a theoretical invisible field which pervades everything in the universe and gives mass to all elementary particles. Here's where we have to delve into some particle physics. Elementary particles are the smallest materials to exist and make up all matter in the universe. You might think those are atoms, but atoms are made up of even smaller particles, electrons, protons, neutrons, which are made up of quarks. This sounds complex, but it can be explained using the standard model. It states that there are two types of particles, fermions, like quarks, neutrinos, subatomic particles, and they make up matter, while bosons carry forces. We measure and categorize these particles through characteristics like mass. But where does mass actually come from, and why do certain particles have the masses that they do? That's where the Higgs field comes in. The Higgs field permeates everything, so when a particle passes through it, it gets mass. The more a particle interacts with the field, the more mass it gets. Then what's this Higgs boson we started off with? Let's use the famous analogy. A packed crowd of particle physicists at a party at CERN represents the Higgs field. Since no one wants to talk to him, a tax collector, or particle easily passes through the crowd to make his way to the bar. These particles, which easily pass through the Higgs field, like photons, are called massless. Suddenly, if Peter Higgs walks into the room, physicists would eagerly crowd around him to discuss his discovery with him. He therefore moves very slowly through the crowd, and the particle gains a large mass. Then, what about this boson? Say a physicist sticks his head through the door to talk about a rumor he heard about a rival lab. The people near the door would clump together to hear the rumor, move back to where they were to talk about it, and then people farther away would clump together and gather closely to hear this rumor too. This creates a moving cluster throughout the room, or the Higgs boson. The boson itself doesn't have mass. Quantum mechanics says that all particles are excitations of fields. So, the Higgs boson is the excitation of the Higgs field. Mass is derived from the interactions with the Higgs field. Both the tax collector and Peter Higgs had no mass until they entered the room and became defined by their interactions with this crowd. By discovering the Higgs boson, we prove that the Higgs field exists, a breakthrough discovery which is continuing to help us unlock the secrets of the universe today. Thank you.